To know more about testing, we want to know more about the phases that are part of the test plan. These phases really, they're conceptual groupings of how do I look at tests. There's many different ways to order this. This is much like the process at the high level. You can do it all by just jumping in and making it happen. But by giving it some structure, it helps you know you're doing the right thing and you're doing it organized and you're doing it in a good approach. So different phases of your testing might include the ones we saw in the previous video: unit testing, integration testing, so on and so forth. We'll walk through each of these in phase. These are high level. At some point, you're going to dive into them. And when you dive into each of them, they'll start to look specific. In unit testing, your goal is to test all the code. In integration testing, you might pop up a little bit and just make sure your systems work together. In functional testing, you're going to check all the requirements out, which might be very close to some of the tests you did in the coding level. So these are less distinct activities, so much more as an organizational way of looking at these. Often they're treated as distinct. Often they're treated as separate teams, separate approaches, but they don't have to be. We don't always have to think of testing as something that's big, expensive, high-level separations. These are just ways of dissecting and bisecting and looking at this. And most importantly, they're always going to be different. There's no test plan that's the same on any project or even on any phase of a project, because it's a living document based off of the needs and what's going on. The bugs you discovered last week are going to impact the plan for what you're going to be testing next week. So it's really important to reemphasize here that building is not testing as far as we're talking about it here. We have to do the act of testing as we build it. We don't stop building if our tests don't work. We don't just, hey, I wrote some code here, there you go test it. Of course, we do build this stuff, but technically speaking, it doesn't count. We want that verification with some formality. Now, there are approaches that do things called test-driven development, that you start by building test cases and then you go from there. And that is closer to the formality we're talking about, because you're documenting and you're even automating in those cases test cases. And that's what's important here, so much more than what you say you're doing is the core, that you're automating, you're documenting. And so unit testing is more than just, hey, I wrote some code and I tested along the way. The idea of unit testing is we've broken down the system into its pieces, and we're going to test those pieces individually. Each interface, it could be at the class level, it could be at the method level, but more likely it's going to be at some sort of higher breakdown of the system, because testing each class can be very cumbersome. So we test these components independently of everything else. So let me give you an idea of this. For instance, if your alternator breaks down, how do you know if the alternator's bad or there's something else that's feeding into that? Well, one of the things you can do is you can pull your alternator, take it over to your local auto supply store. They have a little machine you can toss it onto, and they'll spin it and see if it's working. That's a type of unit testing. I'm going to test the alternator by itself, disassembled from the rest of the car. In a different context, let's say you are trying to get your entertainment system up and running. You want to know whether your DVD player is working because it's not playing in the entertainment system. Well, you might grab your DVD player and run over to your old TV, plug it in directly, and see if it works there. If it plays DVDs, the issue is not with the DVD player; it's with the big entertainment center. Just a couple examples. Automotively minded, electronically minded. Hopefully one of those resonates with you to understand the nature of unit testing. It has its own interface. We test it by itself as opposed to everything together. The goal then is to ensure that we have all the details of what that thing does. It may or may not line very well with the requirements. This could be code that we needed to write just to make the system work. The goal is every piece we build is there to ensure all of this stuff works. So we're going to test all the features, all the functionalities that make sense. Again, the context of this might be different. You might not test absolutely everything because maybe some of it was written already, tested already. Maybe parts of it's going to be tested later on anyway. So who knows the approach to this? But the idea of this is formalization, that we have a process. We know unit testing is a formal unit testing because we've documented, or even better, automated what's going on. Unit testing is very labor intensive. There's a lot more work to write down the details. There's a lot of work to write the automated test that's involved. And so typically this is done by developers. Sometimes it's done by a second set of developers, which aren't the ones who wrote the code. At that point, it could be separation of duties inside of there. It's not typical for a third party to jump in. But that's where unit testing becomes more formal than, yeah, I wrote some code, I tested it as I went. Integration testing then is when I take those pieces and put them back together. So I know the alternator works, I know the engine works, I know the piece works. Let's plug them back together and make it work. I know the TV works, I know the sound system works, I know the DVD works. Let's put them together and make sure it all works. The main purpose of integration testing is not to repeat all the testing you just did. We don't necessarily need to do that. I mean, if it's automated tests, we might just make sure everything's still working. But the goal of that more so is just to get a good feel of, does these things work together? I don't need to test, both the DVD and previews and there. I mean, if I see a picture on the screen, my DVD player's probably working. I don't need to pause it. I don't need to rewind it. Those are the DVD features. So often integration testing is really a formal sign-off of, yes, the system is ready to progress into further testing. Often it's still, again, done by developers, but it might be as part of your test plan to ensure you're ready to move forward from there. So this can be done independent. Sometimes it's done on its own to validate and make sure that two systems, particularly if you're talking about integration between two large systems and two separate vendors or something like that. Most of the time, though, it's whoever's writing the code. They throw the pieces together. They use whatever approach they want to, and even more often just integrated with the functional testing. We don't have a distinct integration phase outside of perhaps on the schedule. We throw a week out there saying, hey, make sure the whole thing is ready to go. Put the code out there, start to run some tests, make sure it's happening, make sure everything's integrated before we really have the plan out there. So if anything's wrong, if anything needs to be passwords updated, encryption schemes change or something like that, then they can be set up appropriately. So our core testing, what most people think of as testing, if they think of it, is functional testing. And so functional testing really has all the components put together. The whole system is being tested as one based off of the requirements we have inside of there. The core of this is the functional requirements, but we also want to consider security, support, administration, air handling, all those sorts of things within our functional testing. This is the case where we're saying that this system behaves well, that we can't break this system easily, that no matter what the users do, our system will be in a state that at least does no harm, ideally does something useful, which might be at a minimum warning the user like, hey, I can't do anything more useful than tell you I didn't do anything wrong. But all the requirements, can we add, can we delete, can we buy, can we sell, can we create a claim, can we, whatever the pieces are going to be, those all come up in this functional testing. It's almost always done independently, especially if you're talking formal testing. It's almost always done by somebody who's not developing on there. And we talked about having the extra set of eyes is really valuable towards this. And more importantly, it's almost always tracked. We know what tests we plan to do. We are marking them off as we get them done. We know what's passed. We know what's failed and need to be retested later on. And so we can evaluate and guess what are the defects out there and how long is it going to take till we get an acceptable release. There's a lot of great details that could be understood on this process. We're not going to get to them here, obviously, because we're just got a week on it. But it is a great activity for making your project more efficient, your product more effective, and really being able to create quality software. Another phase you might consider as part of your test plan is regression testing. Regression testing is any of the test phases we're talking about, but in smaller form. We have certain things that we know work, and so we're doing less testing because we don't need to test those things. So if I just tested my alternator, I know it works, but I made a change to the spark plugs, I don't necessarily need to go test that alternator again. I can pass those tests over. So I just do less testing focused on the things that are broken, but maybe do a quick pass over, does the car start? Does it kind of turn off and restart it? So I'm not doing all the tests on the alternator, but I'm doing a general test to make sure it's still doing its job. That's the idea behind regression testing. Performance testing then is saying once you think the system's working as desired, once it does everything you want to do, and normally it's done later because the performance is going to be impacted. If you're doing the wrong stuff very quickly, it's not doing any good. If you're doing the right stuff and it's slow, it could be just as useless as doing nothing at all. So performance testing is making sure the non-functional aspects are measured. Does it do it quickly? Does it use too much processor? Does it fill up the database? Is it secure? Is it easy to use? Does it use the right colors? All these non-functional aspects is what performance testing is focused around. Performance testing really is driven by the non-functional requirements as much as anything else. User acceptance testing is a very light form of testing, typically driven by what the users want to see. It might be as simple as putting the site, a website or app in the user's hands and saying, how does this work? Do you like it? Is this meeting your needs? It might be more involved as, like your business team might want to do some very specific tests. Might say, hey, these are the things I want to check out. Typically, user acceptance is done by a business-focused team, either the business representatives themselves or a test team that works on their behalf. It can be formal or informal. Its net results really are challenging because if it doesn't work, it might lead you back to the drawing board. It might have been bad requirements. So often user acceptance testing is a final checkoff to make sure things are fine, but there's other things that are used to mitigate what's going on with user acceptance testing. One other thing to mention here is all this great testing is happening. The code goes out, it gets deployed. We often will do a final check to make sure it actually does what it says it does. Sometimes, there's existing old production data that may or may not have been accounted for in testing. Or when I go off and try to use the PayPal, the real PayPal account doesn't work because I have the wrong password stored. I still have the test password out there. Or anything that could go wrong. And so a post-release checkout is saying we deliver the software. Before we turn it on for the users to access it, let's proactively make sure everything's still working. Often this is very difficult to do without actually coding in some plans. I can't go buy a car for real, spend $20,000 on a credit card in order to do that because then I'm paying the credit card company some percentage of that amount. So I might need to plan things specifically to fake it. I might have to put those in the requirements in the system to build or find other ways to work around that. And the last one I want to talk about, the hidden tests inside of there, are reviews. Testing is a very reactive way of introducing quality. Oh, you did something? Let me look at it. Oh, wow, that's bad. Let's fix it. And that did something for live systems doesn't come to the very end after you've done all of your requirements, all your design, all your coding, and then you're getting out there. Reviews are something that you can do at any point in time. Let's review the requirements. Is this what you want? Let's review the design. Is this the right way to build it? Let's review the code. Does it look like it's built appropriately? So tests are vital and also should be reviewed to make sure the tests are testing the right thing. So always consider reviews as part of your bigger picture. So that's a look at the testing phase. This is a lot of information here, and there's so much more that we could be talking about, but take this and consider this as you start and get ready to plan your testing.